a short intro as usual?
Yeah, so I'm the founder of Zeta Alpha, and I'm in AI for a long time, and it keeps getting more exciting. I think I'm not a AGI believer, but there's been a lot of talk this month about it. So about the pace accelerating.
Yeah, so my name is Sergio Castella. I'm the AI community manager at Zeta Alpha, and that means that I try to stay up to date with what's happening in the world of ML. So every month I write this blog post trying to put together very interesting new research and news of what's happened in the past month, which is partly what we base this webinar in.
All right, let's launch into it.
Yeah, exactly.
So we start with some news. So we mentioned before that Sulaiman, the founder of Deepmind, and Reid Hoffman, the LinkedIn founder, started a company. Looks like they found a lot of investors. Well, of course, the rich get richer. And so they raised 225 million. So I think they're a unicorn without having a product or revenue or even maybe an idea of what they're going to do. So that's pretty wild.
A new record?
I think that's yeah. On the more sort of solid side of machine learning companies, we saw that a month ago, actually, Huggingface also raised capital. They raised on 100 million. Well, I would think that I would rather invest in Huggingface than Inflection, but yeah, they're pretty solid business and have a lot of grassroots support. We'll mention them a couple of times because they're making waves all over the place.
Mm-hmm.
What do you think about GitHub Copilot being offered free to students?
Yeah, I guess that's an excellent business decision to hook them up so that later they have to pay, right? I've heard they do similar thing with MATLAB. I suffered that as a student. I got it for free when I was a student, but everyone hated it so much that everyone went to Python afterwards.
Right. Well,
it's still widely used in some.
I'm kind of old-fashioned, but I think students should learn coding and not learn code completion. But
no, that's a good point. Yeah.
The future is yeah, people will also not learn how to drive, right? So presumably, but it's not always going so smoothly because apparently Pony.ai, the Chinese self-driving car conglomerate, lost its permit to test autonomous vehicles in California. So I don't know what happened, but went wrong. Last month we showed you how Cruise got pulled over by a cop and then tried to speed away. Maybe something similar happened. I don't know. And obviously there's also considerable attention on regulation from government, but also from companies. They are getting more and more pressure to kind of have you know, reasonable policies about AI. And deepfake generators are not considered very nice. So Google banned them from Colab. I was wondering, would you consider, I was talking to the deepfake detection startup that makes a product. They're called DuckDuckGoose from Delft, and they make a product to detect deepfakes. So it's kind of a, how do you say, an arms race. Would you consider DALL actually to be a deepfake generator? Does it deepfake art or does it create art? I don't know.
Well, I do feel interestingly, DALL-E 2 has the capabilities of in-painting pictures, right? So you can basically not generate an image from scratch, but like kind of mask part of an image and then generate on top of that. Yeah. I believe because of the diffusion model, how it works. So I guess that kind of enters a bit in the realm of deepfakes, where you can very kind of, I don't know, cleverly make it look as such as like certain people did certain things or something like that. So I guess that's more related to deepfakes.
All right. So in further news, this was a pretty big riot in at least on Twitter, but I think it's making its waves into the mainstream media. Vice covered it, but I think we'll also probably make the weekend editions of the newspapers.
Yeah.
Yannic Kilcher, the YouTuber, that does this really good paper explainer videos. He did this kind of a little activist adventure. Can you explain what he did?
Yeah, sure. So he basically grabbed the GPT-J open source model from Eleuther AI. I think that we had talked about that. It was the biggest open source model for a while, like language model, a bit like GPT-3 autoregressive generation of text. And he fine-tuned that on 4chan data, which 4chan is this message board that is pretty much the Wild West, where there's no moderation, and it's really like a home for a lot of, like extreme political dissent and alt-right movements and a lot of these things. So there's a lot of very nasty language in that. So he basically trained it with that to see what would happen, and then made a bot that would publish on that side and see what kind of engagement that prompted.
Nobody noticed.
That's the thing, that nobody noticed for a couple of days. Right? And everyone was very puzzled about it. And there's a lot of super interesting ramifications. I would highly recommend you watch the video, because it's really, really well made and super interesting from both the technical perspective and also like this more kind of broader social impact perspective, right?
But then already when he published the video, a lot of AI ethics folks on Twitter started yelling at him that this was not a good experiment with human subjects. And it really got worse when he open sourced the model, right? Remember how OpenAI delayed publishing their GPT-2 model? Because it might be harmful, like maybe. Well, this model is like admittedly not a nice person to talk to, right? It's the bully, racist, it's sexist, it's not a good netizen.
That's absolutely true, and that's pretty much the point. Like, it's trained on bad on bad language, so that it generates this kind of language. And it's true that it's been super controversial, the fact that he made it very accessible. It's on GitHub, on a Huggingface model repository, so you can easily download and use that.
Well, no longer. So Huggingface was actually pressured to kind of close the access to it. So they have the model posted there, but you can no longer do inference with it. You can not build demos with it.
I see.
Also not download it. It's more like documented there, because they had this, like data cards, and where you would have to declare.
They make it super. Yeah, they make it super easy to try it out, and that's kind of very easily kind of used for unethical purposes. But I didn't know that they had actually pulled off the access to that.
Yeah, it's no longer downloadable, and I guess that's okay, right? Depends on your position. I think a lot of people are still upset with Yannic, but in my personal opinion, this whole prank or adventure has actually made a very nice discussion case for AI ethics classes.
Absolutely.
Like actually making it, kind of pulling it down from abstract harm to something very specific to talk about. So I think it's an interesting case. But
absolutely. And I mean, he also uses that to make the case that Matthias in the chat just mentioned that, which is that he shows that this benchmark truthful QA, which is often used to evaluate how truthful language modeling generation is, that this model apparently trained on very bad data actually outperformed GPT-3 and GPT-J on this task, which is kind of a bit puzzling, I guess. And he kind of used this actually as a kind of more of a critique to this benchmark, to say, hey, this benchmark might not be that trustworthy if training a model on 4chan gets you state of the art on that benchmark. Which is a very, I guess, a very valid point to say maybe we need better benchmarks on the on this area of truthfulness.
Yeah. And it's not like anybody else cannot download 4chan or any other crazy stuff and just train a model on it, right?
Absolutely.
All right, let's move on. So another piece of news of last week. Yeah, obviously, Facebook AI research is a very big powerhouse in especially in open source models, and they're being very like accessible and open about their research under the direction of Jan LeCun. So they pretty much reorged all of it. And yeah, you can read the announcement on the Meta website, but basically they're gonna move around all the different parts and put them under product teams, and they're set out to build the metaverse. Like their goal with AI is to build the metaverse. And when you think about that, and we've all seen The Matrix, right? And it's also not a good future scenario. So there's this huge company, and it's really determined to build The Matrix. I don't know if that's such a good idea. So maybe some of these people leaving have to do. Yeah, the COO also left. I don't know.
It does feel like a very bold, long shot sort of bet, right?
Maybe more bad than bold. I don't know.
But yeah,
not rooting for it to succeed.
maybe bold is not
all of humanity with glasses strapped to the umbilical cord of Meta.
It just feels to me like a little bit of a strange out there bet to make for such a big company to so openly bet so early.
About this reorg is that we can call Facebook AI research fair again, but now it stands for fundamental AI research at Meta. So a little bit of a wordplay there. We wish everybody well. And they're very good at with PyTorch. Obviously, they kind of blown away. I spoke to somebody from Amazon earlier today, and they used to have this internal framework, completely switched to PyTorch. So now PyTorch is also on Macs. Yay!
Yeah, on Apple Silicon. I remember when Apple Silicon was released like a year and a half, I think, ago, or almost 2 years now. A lot of people were wondering how long it would take for PyTorch to, and then people were very eager to see that happen. And there it is now.
Wow, yeah. In related news, Apple actually also released a native transformer library that is really optimized for the Apple neural engine. I think that's the chip that's in your iPhone. So transformers in edge devices, that's also a big thing. And Apple released theirs. But I'm curious why Apple never really kind of, put their resources to to make this PyTorch port go faster. Like faster, come earlier, but also if you look at the acceleration, is it really that impressive? I think it's less than on NVIDIA.
I don't have the numbers on top of my head, but it could be. But I do think it's very interesting to see that, right, that what you said, Apple is really making the bet of going kind of edge with their privacy bet and all of this, and they're really trying to push the machine learning to happen on device, and they do a lot of machine intelligence on device, whereas Google seems to be going quite a bit in the opposite direction and focus a bit more on the large scale server side of things. I think it's gonna be interesting to see how those bets pan out in the longer term.
Well, I wouldn't want to train my Palm model on my edge device, but I sure would like a bunch of good TPUs to do that. So
yeah, but you wouldn't want predictive text probably running on some on some Google servers as well. So
yeah, so I think Palm and GPT-3 is still a bit out of reach for most people to deploy, but the Facebook OPT model, the 30 billion parameter version, was also released on Huggingface. So that's I don't know, was it also trained on 4chan? Is 4chan part of the training data? I guess not.
I think that they were a bit more on the safe side when it came
We're
to
pretty
filtering
cautious.
the
Yeah,
data, and yeah, cautious. Yeah,
yeah.
for sure.
Still,
It's still output a lot of toxic language, as they disclose in their paper.
exactly. We talked about it last time. All right. So yeah, with that kind of the main news headlines. So we are Zeta Alpha. We built this platform, which is an integrated tool to discover, organize, read, and share for AI and data science teams. And it's really good recommendations. How does it work? Well, basically, you discover content by searching, very powerful search using neural dense retrieval. You can easily find similar, do visualization, discover what's trending on social media, which is actually part of how we do this sort of monthly collection of papers that we're going to jump into in a bit. You organize your project in personalized collections using tags. You can read documents, add them to tags, annotate them. I'll show a little bit of that. And then that generates recommendations for you that you can use to stay in the know, keep things on your radar, or make a monthly Trends in AI webinar, right? So just a few things that I want to pitch on the product side. So this PDF reader is pretty new, allows you to kind of, as a team, share your notes and annotations on PDFs. And we've now finally pulled it through to be usable in mobile settings. So it actually works on tablet, on iPad, on Android, on your phone. So check it out. This is kind of how it works. So you have the PDF and you can make images and notes and select portions of text and then share them with others or comment them and all that works. And then if you have these notes, you can actually use them to do contextual search for related work or for just looking up or discovering more about that topic with one click. So that's pretty cool. And that's, of course, due to our backend capabilities in neural search. So I'll end the product pitch here, but we're working very hard to launch the exciting next chapter. So the data that we have in our platform is all about AI and data science, papers, blogs, code. But if you're working on the edge of AI and another discipline like medical imaging or logistics or chemistry, then you don't find the other literature, which also uses AI more and more in our document collection. So we're working to cover all of science, basically, and put that in your pocket for discovery, organization, tagging, recommendations, sharing. A lot of it. Pretty exciting. Hang on. It's not ready yet.
At ACL, right? That was 2 weeks ago now already. One of the, I would say the first very big or like major AI conference that went physical.
In Dublin, yeah. Like half of the people were actually physically in Dublin, around 1,500 people. And the other half were still in pandemic mode at home behind Zoom and all that.
Mm-hmm.
So it was actually pretty hard to attend online because it seemed like all the action was actually on site. And
I guess it's a common thing with hybrid conferences right now that we've seen a few.
Yeah, so it's a bit hard here to give a full overview in a couple minutes, but you see the visualization of the conference and yeah, it's 1,600 papers. So I think you want to take your time to browse through that a little bit, discover the different topic clusters and everything. We saw that majority of the papers was from the US, even though the conference was in Europe. But if you add up all the European countries, they actually would make together the second contributor, more than China. And the biggest, I was surprised by that. The biggest company contribution, or the biggest contributor at all, was not Google or Deepmind.
Microsoft, right? I'm seeing here.
Yes, Microsoft. So
that's not the same. I think for NeurIPS we did a similar analysis, and I think that Google was, right.
Yeah. So kudos to Microsoft.
Mm-hmm.
A couple of papers, you can read this on our Twitter. The best paper award went to learned incremental representations for parsing by Nikita Kitaev, Dan Klein, and Thomas Liu from Berkeley. And a pretty interesting paper that introduced a new data set was beyond goldfish memory, kind of long sequence of dialogue states data set. And I think this one you discovered, right, Sergi, the link bird.
Mm-hmm. Yeah, they do some pre-training leveraging the links. I believe is in Wikipedia corpus, and yeah, they show them.
Got quite some attention. There were also workshops. There were, I think, 20 plus workshops, and this is where really the virtual conference shines, because if you don't want to choose for one workshop, you just kind of watch them all. So these were some of our favorites. Huggingface Big Science presented their progress. That was pretty nice. Kind of the details of all that large model training is still not done. We're still waiting. Mm-hmm. What was this? NLP in e-commerce. That was a pretty cool workshop. Kind of like, how do you do product search and recommendations in an e-commerce setting? There was this paper, Does It Come in Black, which I thought was pretty cool. It used a kind of clip-like model to be able to use natural language to select a different product by its image.
Mm-hmm.
And two other pretty nice workshops were semi-parametric methods, so about this kind of retrieval-enhanced class of models that are kind of becoming the norm, I think, in
absolutely.
a lot of tasks, and a workshop on representation learning. So that's for ACL. Well, there's always also the human touch. So I did want to mention that Priscilla Rasmussen, I think she did for 30 years the organization of ACL. She's retiring, and she got a standing ovation from the crowd.
Wow.
And one of my sort of human touch highlights was to see Jason Weston do his talk on Zoom. And I was like, he has a pretty nice shirt on. Then it turned out to be a cow onesie that he was donning. So
yeah,
I'm not sure he would have worn it if he would have been there in person, but well, call of a character. All right, floor is yours.
All right, yeah. So we move on to the section more focused on the blog post that I wrote earlier this week. Like I said before, we try to collect some pieces of news and focus also a lot of research papers, selecting 10 research papers from the past month that we believe are interesting, insightful, or just kind of overall very cool. And you can read on our blog at zetaalpha.com/ well, you can just find it on our website. Yeah, and this week, I mean, we had a lot of language, like usual language model stuff, a little bit of reinforcement learning, some computer vision. So yeah, let's just jump into it.
You make it sound like you've read all 9,000 papers and then selected 10 out of them.
Yeah, no, certainly have not. I really use the platform, and also the recommendations that come in really handy, and also the ranking by Twitter popularity, for instance, is something that we use quite a lot, because Twitter is pretty useful at highlighting some very interesting papers that the authors share. So that I would say is probably the most. It's a social network where a lot of academics discuss and sort of share their work. So we use that a lot.
This was not in your blog. It's a late breaking.
Yeah,
It came out yesterday.
From yesterday. Yeah, I've seen it.
This paper
Always
absolutely sets the record for the number of authors ever in AI, I think.
Yeah, 442. Yeah. It always happens that there's like some paper right after we publish our blog, right?
So I have to admit, I did not read it yet. It's 100 pages. And the first page is entirely devoted to listing all the authors. But what this paper is really a new benchmark, which obviously makes a reference to the Turing test, right? The imitation game is kind of the original concept developed by Alan Turing to describe his human versus machine test. So it's a kind of new collection of many different tasks, partially completely created from scratch with kind of difficulty for humans and machines in mind. And what they did is actually not only collect this data set, they also benchmarked a couple of very recent models like Palm from Google and GPT-3 from OpenAI and the trillion sized switch style sparse transformers. I don't know, AGI, superhuman performance, but actually somewhat to the reassurance of critics, they found that the absolute terms performance when compared with humans was rather poor. So,
yeah, we'll see. I mean, I think that benchmark papers are extremely interesting because you see that it's really what's driving, right, a lot of the research and really having a very standardized, hard to beat benchmarks that are not yet saturated is crucial to have progress. So it's going to be super interesting to see how long it takes for.
I didn't read the paper yet, so I'm not sure whether this would count as passing the Turing test. But I think the ambition of this paper is certainly to be in that direction.
Yeah, something that doesn't saturate as fast as like super glue or like these glue benchmarks type of things, right?
Check it out, Gato.
Yeah. El Gato from Deepmind. This was huge, right? I think it was a couple of weeks ago. Everyone was talking about it for a few days.
Yeah, it is a very kind of thought-provoking paper. So let me explain a little bit what they do. So basically, they have this kind of unified model, which is kind of situated in a reinforcement learning context. But different to other models for reinforcement learning, like AlphaZero or agents that learn robotic movement, it learns all these tasks at once. And it doesn't only learn all Atari games and robotic movement, but it also learns vision, language, motor, and video game commands all at once. So if you're talking about like a general agent that's intelligent across many different tasks, including language, vision, and motorics, that sounds an awful lot like artificial general intelligence, right? So it got people really thinking. So what they did was actually they took 604 different tasks and trained this transformer model, which wasn't so huge, but they trained it mixing all these tasks together. And then basically through a prompting strategy, I know that's one of your favorite modern approaches, Sergi.
Absolutely, yeah.
So you can say like, what is the task? And then you prompt it to do that kind of behavior. And the result was that on 450 out of 600 tasks, it scores better than half of the expert models.
So you'd say like comparatively to humans, right? Or
It wasn't really compared to humans. So these are not hand-labeled sequences. They're not. It's not like supervised learning.
Oh, yeah, yeah.
More like a distillation. So it
Mm-hmm.
takes reinforcement learning agents trained on a single task, which might have like better than human behavior on chess or whatever, or on Atari games, and then takes a whole bunch of them and then scores whether this model performs better than the average there.
Mm-hmm. Yeah, to me, one of the most interesting, or at least one of the takeaways I take from this paper is once again the power of plain autoregressive like modeling, basically, of like this idea of like predicting the next, just predicting the next token. It seems to like generalize so well to a wide range of domains, and it still really feels like the limit hasn't been reached to how expressive this a model can become only with this objective function. So I think that,
it's just mixing in all these things during training in a kind of sequence to sequence model.
mm-hmm.
And basically it's like a teacher student type of setting, right? So it's really kind of distilling multitask from different models into one single model by mixing the training data from the teacher.
Mm-hmm. Yeah, actually, that's a good point. A lot of the, unlike a lot of the big language models, most of the data that the Gato is trained on is supervised data, right? So they gather a lot of data sets and put that together, but it's not all self-supervised.
And so basically, it's a fairly small transformer model, 1.2 billion parameters, and they tokenize all these different tasks in different way. And that's really kind of the multimodal thing, right? They tokenize images using patches from ResNet and text, kind of the classical BERT way, and Atari button presses are tokenized in a certain way, and then there's like concatenate all these token vocabularies, and then it's like a unified sequence to sequence model. The criticism that immediately came on Twitter was that actually is not really a reinforcement learning setting. So it's not really learning a policy, it's just learning to model these sequences. So there's no like reward loop with learning at the end. It just gets the labels from the teacher models. So this one sentence, I think, kind of reflects the criticism. For simplicity, it was trained offline in a purely supervised manner. In principle, there is no reason it could not be trained with reinforcement learning. Well, that's still a lot of work to make that happen. But
like we leave that as an exercise to the reader, right?
Yeah, exactly. And yeah, there's some related work, multi-game decision transformers. But I think most of the discussion that broke out was not because of the paper itself, but because of this tweet by Nando de Freitas, who's the research director at Deepmind. He said, well, I think the game is over. This is it. This is AGI. The rest is about scaling. So
as a quite a strong position,
strong, statement, and I think there's a few more tricks there, like doing it in a reinforcement learning setting. But all right.
No, but I definitely feel like this work kind of proves that this is possible. And I mean, like you said, the scale is not that crazy. So I'm really wondering what happens when you scale a very similar setup to something like a couple of orders of magnitude higher, like GPT-3 scale. And what kind of behaviors emerge when you do it on that scale?
Well, the Gato paper is like 3 weeks ago. It already feels like it completely sunk in, and everybody changed their perception. I read somewhere, but I couldn't find the tweet back, is that actually there's this kind of polling of AI experts on when potentially machines will pass the Turing test. And I think after this paper was dropped, that average kind of went back or forward to a couple of years. So definitely made a big impression.
Definitely. All right, let's move on to the next paper. We're slightly late. So I love this one. So diffusion models is something that we have talked about for quite a bit. I think that they were introduced not that long ago, like a bit more than a year ago, but they like suddenly became the state of the art for image generation. So much so that like now, for instance, DALL-E and Imagen from Google are based on diffusion models, and they're being applied to a lot of things. And one of these new ideas that some people have applied it to, Michael Jenner and colleagues, is for planning in reinforcement learning. So for a bit of context, normally model-based reinforcement learning, what happens is that you have a model that learns the dynamics of the environment, and then you have some sort of classical trajectory optimizer that does the decision-making. And what they try to do in this paper is to apply diffusion models to introduce as much learning as possible into the actual decision making, which is what accounts for the trajectories, or like the planning. So you can see in this GIFs the sort of like the kind of gist of it, of like how this idea of diffusion, of like adding noise to an optimal trajectory and then kind of learning a reverse process on that, learns a way to come up with optimal trajectories. And I think that this is fascinating, as it kind of like opens up this whole new world of possibilities of doing reinforcement learning with diffusion models that is quite a promising direction.
The way I understand diffusion models is basically like a fully differentiable model to generate noise, right?
Absolutely, and yes.
To fit it to a target distribution.
Exactly. So then if you have a fully reversible process, if you learn kind of the process one way, you can just flip the process and know how to generate it. So like if you basically have an image and keep adding noise progressively, and learn the model to reconstruct it that way.
It seems to be much more robust than like guns or stuff, right?
Absolutely, yeah.
I remember that Jan LeCun always talks about energy-based models. And I think these diffusion models are actually kind of the incarnation of that idea of energy-based models.
Yeah, I haven't thought of it that way, but it's probably something that can be kind of understood through that formalism.
Yeah, well, they're all over.
Yeah, they're definitely, and they're gonna like a lot more coming.
And you're working in computer vision, but even in reinforcement learning. I even saw a diffusion model paper in NLP already. So.
I saw some applied to image generation, where they progressively like added noise to basically text, and they did like denoising based on this diffusion process, right, which was very interesting.
I think this one also uses diffusion models, right?
Yeah, absolutely. The Imagen, this is kind of very interesting because we had DALL-E come out in April, which was definitely like the highlight from that month. And then Google came out with this model that is very, very much an analog to DALL-E. Also a couple of weeks ago, and yeah, it's very interesting because it's similar to DALL-E in some ways, but different in others. So basically, the similarity is that they also use diffusion models for generation, because it's like we said, it's like the most robust and more like stable way to generate images. However, they do some upscaling, like they call this super resolution. They generate from 64 by 64, then 256, and then the final resolution is 1024, which I believe that DALL-E does directly the
full image.
The full image directly. But the most interesting difference that they study in this paper is that they encode, like, to do conditional generation on text, you need to first encode text into some embedding and then use that to generate the image. And here they basically use a frozen pre-trained transformer that has been only trained on text. So I think they use a T5 model, and then they use that to encode. But the interesting thing is that this model has never seen images, right? So it has to generate some sort of useful representation that's going to be useful to generate an image without actually having seen images. Whereas with DALL-E, they use CLIP, which is an image that is a model that is trained contrastively with contrastive learning with text and images. So it's like a multimodal thing. But here they find that these encodings from, well, these representations coming from a transformer trained only on text are already really good to generate images, which is super interesting. And moreover, they also find they have some very interesting analysis on where does it pay off better to scale the model? And they basically find that having larger pre-trained model really makes the end the images generated very good, whereas scaling up the diffusion process doesn't yield similar results. So like if they're gonna spend a lot of compute resources or like parameter resources into something, it's really in this frozen pre-trained transformer, which has not seen images, which is kind of a cool.
Which has all these creative components about how these concepts combine in sentences and how the compositional semantic latent representations should work, right?
Yeah. Exactly. And I mean, it also displays, I mean, we've seen only cherry-picked results, but it does seem to display a lot of the DALL type capabilities where you ask it to, you know, to output something very crazy in weird styles that have definitely never been, like, that have not happened in the training set ever, for sure.
Chinese dragon typing on a laptop in medieval dynasty style, yeah.
Exactly. So all of these things, it's crazy how much you know, like, of this compositionality actually gets right. Of course, there's still failure modes, like, full disclosure, but I'm really looking forward to some people actually really comparing head to head with full access to these two models and see what the failure modes, how the failure modes are different, or, you know, all of these small things I think are going to be very useful to understand how these models work a bit better.
I think the consensus on the internet is that Imagen slightly wins because of the quality of the images, like the photorealism of the images, especially.
Yeah, I mean, it's hard to compare because we still didn't see like full access to the system.
Here are some more examples.
A dog looking curiously in the mirror, seeing a cat. Yeah. Very creative things. Yeah.
Crazy. All right. Well, this I thought this was actually an ACL paper. It came out during ACL, but it was just dropped on archive. Most of the ACL papers were actually quite a bit older. There were a lot of papers there that had already been on archive for like 6 months. This was a nice new one. And you know, you have all these tasks where the goal is kind of common sense reasoning, or even some basic arithmetic, mathematical reasoning. And the first sort of attempts to get GPT-3 to do these kind of tasks were not very convincing. So there was a lot of criticism that these large language models lack common sense. And now people have really discovered, and this paper is an example of that it's really about the prompting. So you have these kind of little puzzle here. On average, Joe throws 25 punches per minute. 5 rounds of 3 minutes. How many punches did he throw? If you would just prompt directly for the answer, the probability of getting the right answer is not very high. I think like 18% or something like that on average across these tasks. And just by adding this simple sentence, let's think step by step, which kind of provokes the model to generate language in a kind of stream of consciousness type of reasoning mode, yields this incredible result that now the answer is about 80% likely to be correct. That's pretty amazing.
It's insane. I mean, to me, this shows how much, you know, how rich this whole prompting space is, and how much there is to be discovered. Or like this kind of discovery seems such a, I don't know, like obvious thing in retrospect, or like something so simple, yet it's so powerful that yeah, I'm super excited to see where people take these
like people, this prompt is bringing the best out in you, Sergi. When we talk about prompt tuning, your eyes start to shine.
Yeah, no, absolutely. Yeah, I'm very happy that this prompting thing didn't fizzle out, because
so next year ACL is entirely devoted to prompt tuning, maybe. But there was a little bit of criticism. I'm not sure if it's deserved. There was somebody on Twitter saying, or like suggesting, that this specific phrase, let's think step by step, was actually used during the pre-training process of GPT-3. So it's in some sense maybe like an Eastern egg feature, like a hidden backdoor to get better behavior. I don't know.
Yeah, I mean, we can't know because the details of the training are not open source, right? So
because it's from OpenAI, then of course it's not. All right. So next paper. This is also a pretty new one. I think it came out last week or something like that.
Yeah, not a lot more than a week ago.
Yeah. So I mean, since when do we have vision transformers? Like a year or so, right? A little bit
No,
over.
I think a bit more. I think that VIT was like 2020.
All
the
right.
original, like an image is worth 16 by 16.
Yeah, like the very first one, and then last year they took over a state of the art in on ImageNet and stuff, and there was a bit of shuffle whether convnets are not about as good, but now there's again a new kid on the block because graph neural networks have also entered computer vision. So I think this is one of the first papers which really does a very convincing job of applying graph neural networks to the general sort of ImageNet object recognition problem, right?
Yeah, and their method is quite remarkably simple, actually. So they basically split represent images into graphs by splitting the image into patches and then embedding those patches and then doing some nearest neighbor search to define a connectivity of this image, and then they feed that into a graph
nearest
neural
neighbor
network.
search in the raw image bitmap of the patches, right?
No, I believe that it's in the embedding space.
Oh, it's already embedded. Yeah. Okay.
Yeah. And then they feed that to a graph neural network, and they do have to apply some tricks to make this work. It's not kind of a very much out of the box thing, but like you said,
it does not work so well. But they do some sort of hierarchical thing, and then they get really competitive results. And if you think about that, this is kind of one of the first applications of GNNs to ImageNet. Getting 82.3 top one. It's not state of the art, but
no, but it's still like very much
good first attempt.
Yeah. So I don't know if you agree with me, but what the thought that kind of came to my mind the most reading this paper is like, if there's all of these architectures that do so well on ImageNet, to me that only reinforces the idea that the architecture at the end of the day is not all that important. Like as long as you have something big enough and enough high quality data, you'll be fine.
I'm sure I agree with that. I mean, especially if you talk about images, all the sort of the reason convnets do so well because they have these baked in sort of invariances, right, to translation and all that. So actually, to get sort of the right bias to deal with the mathematical structure of images, you can use transformers, but is not ideal. You still have to use this sort of convnet pre-processing. And I think graph neural nets have this sort of idea that they can learn this bias, or that you can kind of structure them to have the right bias from the very start.
Or I guess another way of seeing this could be also like looking at end performance is no longer kind of very good indicator of how good a model is. And you should start looking at things like how efficient learning is and looking at more of these ablations because that's more informative. Because, you know, if you really optimize a model, you're gonna make it perform well by just finding those perfect hyperparameters and training data set and all that.
So yeah, if I were a Kaggle grandmaster, I would just take all of them and then ensemble them the hell out of it.
Yeah, I mean, an ensemble of everything is probably better than
strategy.
All right.
I think we need to move faster.
Yeah, we need to wrap up quickly. So this UL2, very quickly, can you give us a
yeah, so basically you have all these different paradigms of training language models. masked language models, prefix, cropped, all these kind of different ways of generating the missing tokens. And some of them work left to right, and some of them fill in the blanks and all that. And in this paper by the incredibly productive Google researcher Yi Tai and Mustafa Degani and many others in the group of Donald Metzler, they basically just tried mixing all of those different styles together. And yes, I think the combination works even better than any single one of them. I think that's so like mixing even within a batch, all these different masking schemes produces a really robust model with really high performance.
Yeah, and to me, the very interesting thing is that you can use it in the both paradigms, right?
To generate text and to create embeddings. Yeah.
Yes, exactly. Okay, yeah, very quickly, this unified modeling approach for vision. Basically, what they discuss is that in computer vision for pixel level tasks like image segmentation, depth estimation, or colorization, where you like the output of the model is kind of a prediction per pixel, it's very hard to have a unified architecture to solve the task. And what ends up happening is that to solve each task, people have to insert design choices that are specific for each task. So they try to come up with an approach that is capable of, like, with the same architecture, solve all of these pixel level computer vision tasks, which are very challenging. And what they come up with is that they have this sort of combination between a base model and a restricted oracle. And it's interesting because this restricted oracle is only fed the output, like the ground truth of the output, and it's tasked, like it has to learn a way to encode a discrete set of tokens that will help the base model, so guide the learning of the base model to more efficiently learn this task. And then, like, the results are, I wouldn't say like they're extremely impressive, but they're like at least a good indicator that this is a feasible approach. And it goes in the same direction of like kind of generality, trying to come up with, like what the transformer was for NLP. So trying to come up with what that is for pixel level computer vision tasks, which are very challenging for the fact that the output is very high dimensional.
All right.
Yeah, the gist of it.
So I think this is the last one in your selection, or
I think there's this one and one more very quickly. Yeah.
So let me just give a really quick rundown of this. So this is a kind of, I would say, a reframing paper. There's been all these different models like WebGPT, Retro, Lambda, KNN-based language models, KNN-based machine translation, and all of these people act like nothing happened that happened before 2019 is relevant. Well, some people actually worked on KNN-based NLP in the 1990s, like myself, but I don't mind. It's good to have things come back. But basically, the idea is that if you want to like really store a lot of examples, is not the best way to use your parameters of your language model for that, right? To try to like memorize all of the internet. And it's better to use the scale for the real sort of language semantics and representation learning, and store the actual facts in a associative memory in a retrieval engine. The retrieval engine then has to have certain properties, and here in this paper they show a really nice sort of framework how you can make it all differentiable and what the best loss functions are and all that. So if you're interested in this, definitely read this paper. What I find super fascinating is that it's again Mustafa Degani and Donald Metzler being some of the authors, and Donald Metzler is the guy who wrote this, initiated this whole paradigm of differentiable index, where actually they built a retrieval engine for doing search, all by memorizing everything in a transformer, which seems kind of exactly the opposite of this paper.
Very much, yeah. I completely agree with that, and I have to say I'm kind of I don't know if that's a contradiction, but I'm like very excited about both ideas and sort of like what is going to come out from those two?
I think like Don Metzler has at the bookies at the like at the booking at the betting agencies, he has bets on both, I think. So it doesn't matter who wins. Grokking.
Okay, yeah, and finally, Grokking. Yeah, so Grokking was this recently discovered phenomenon in which neural networks kind of very weirdly generalize way after overfitting. So this has been observed in algorithmic data sets. Algorithmic data sets are things like synthetic data sets that, for instance, have a lot of, say, binary operations like multiplying two numbers. So you basically try to feed that into a neural network, and you make sure that the training only includes certain pairs of numbers. And then you test on numbers that didn't appear on the training set, and then you kind of make the conclusion: did the model learn to multiply, kind of generally? And basically, what happens with this is that at some point, if you feed enough, if there's enough training data, you see how the learning of the model on the training data pretty much like saturates, like it memorizes the whole training data, but the loss on the test set is really bad, so it doesn't generalize. But you keep training and keep training and keep training, and eventually the loss of the test data suddenly goes up, and it's like the model suddenly generalizes way after overfitting, which is something very counterintuitive. So this paper tries to build an effective theory on why that happens. And they basically have this, it's kind of interesting because they have these people, a lot of these authors have a physics background. So they kind of like try to use the physics toolbox in terms of thinking, in terms of effective theories and phase transitions. And like they build these kind of formalisms around this. And they basically predict quite successfully when this grokking happens. And then they have this whole, it's kind of very interesting to have a sort of like mental model to think about these things in some intuitive ways. Yeah, I mean, it's still a question to what degree this will generalize to other data sets, because they still use a lot of algorithmic synthetic data sets. And they say, yeah, we kind of conjecture that this is going to generalize. I mean, that's still kind of an open question. But still, I think it's very interesting to have these kind of tools to think intuitively about this very strange phenomenon.
All right, we grok it. Let's grok the final bit. We have a bit of just a quick rundown of some really interesting things on code on GitHub. I think the most noteworthy is that, again, lucidrains manages to have kind of the bootleg copy of the model out almost at the same time as the as Google releases or doesn't release the original in a paper. So I think the grokking medal goes to lucidrains, definitely.
Absolutely, yeah, it's kind of.
What about this CogVideo?
Yeah, so this CogVideo is the implementation of a text to video transformer that's pretty large. I think it's like it says 9 billion parameter transformer, and it's the implementation of this paper that didn't make it into the selection, but it's also very interesting.
It's from this Chinese group from Jitang in Beijing. It's kind of the beginning of a DALL for videos, right? I think my bet would be that we're gonna see like fully language guided generation of videos before the end of 2022.
That's interesting, but I know that I've heard Yannic talk a lot about learning from videos, and I think that yeah, like he's very interested in this space. I haven't watched that space.
Text to video, right? Text to video. The text to video. Like,
yeah.
Like read War and Peace by Tolstoy, and then make 2-hour feature-length movie.
Wow, I was thinking more about 10-second clips, but yeah, that
little
I would bet against that happening.
Memes. I think this CogVideo is kind of on the level of the Giphy memes that move a little bit.
Yeah.
Right. Interesting package, efficient former vision transformers in mobile devices on the edge from Snap AI research, and a comeback from our LSTMs, right? I think.
Yeah, I feel like every couple of years there's an implementation of an RNN that sort of says, hey, RNNs are actually still pretty good. So maybe you should consider them. But everyone is just kind of moved on to transformers. And I don't know, will they ever make a comeback? I do think that there's some applications where it would make
Low
sense.
resource applications, they're definitely still useful.
Exactly. Yeah.
All right, so that was it. We're on the hour. Just want to take the opportunity to plug a little bit our own latest work. So yesterday, earlier this week, dropped on archive No Parameter Left Behind with our colleagues from Brazil, Rodrigo and his team. And in that, we show that re-ranking based large models have a lot more punch than dense retrieval and smaller models, and we actually capture state of the art on the BR benchmark. So that was a pretty nice milestone for our research team. And yeah, check out our platform if you haven't tried it yet. It has all these cool things and this PDF reader, and very soon you'll have all of science in your pocket with Zeta Alpha. So hang tight for that. Next month, actually next week, we're gonna be tweeting from Berlin Buzzwords. We're going there live. Berlin Buzzwords, if you haven't heard of it, it's a kind of very engineering, like system engineering for large distributed systems. But there's a lot of attention for transformers and neural search in particular. It's all about like searching, storing, and data engineering. So you can attend. It's a hybrid. So for a pretty reasonable price, you can attend the virtual edition. And there's a lot more conferences coming up. So actually, the week after that, there's the Large Computer Vision Conference, CVPR, in New Orleans. I wish I could go. Maybe kind of impulsively, I'll fly out. I don't know. No, but New Orleans is great, and CVPR is great. We'll definitely be reporting on that in our next edition of this webinar. And there's ICML coming up in July and SIG-IR coming up in July. So a lot of conference news in our next edition. Is gonna be, I think, on the 7th of July, right?
Yeah, probably the second Friday of July. Yeah.
All right. Looking forward to that. Thanks for hanging.
All right. Yeah, thanks for hanging, and see you next one. Have a nice weekend.